But I'm going to do a very brief sort of 5-minute overview of this tool that we've just open sourced called Blight. And I've called this Making Build Instrumentation Pouring with Blight. So just to motivate things, here are 4 cases where we actually need to instrument builds. You might be wondering, like, I have a build system. Why would I even care about this? If your build is large, you might need to cache it, or you might want to cache it. So you need to instrument the build so that you can divert compilations to your compilation cache. Example lists are Ccache and SCcache. You might also, if your build is slow, want to profile it. So you're going to want to instrument individual tools that run as part of your build to see which parts of them, or rather which tools or which invocations of those tools are slow. There are also sort of static analysis uses to build instrumentation. Tools like Clang, I think it's Clang Tidy, I believe, take the output of CMake or Bear. Both these can generate compile commands.json. And Clang Tidy and other tools can actually ingest this to determine which static analyses to run, depending on either the C or C++ language version or flags passed to the compilation units. And then finally, for either static instrumentation that's injected or dynamic instrumentation that's injected, we want to be able to inject flags and/or code into individual compilation tool runs. So that's 4 reasons why you might want to instrument builds, just to put them out there. However, unfortunately, correct build instrumentation is a massive pain in the ass. As anybody who's worked in C or C++ knows, there's a massive diversity of build and meta-build systems. On any given day, I work with all 4 of the ones that are listed below. There's also, on top of these build and meta-build systems, there's a diversity of compiler front ends that the actual build system can run underneath the hood. So you have, GCC, Clang, Intel's compiler, MSVC, some terrible vendor. And then each of these has its own complicated CLI that is more or less compatible with the others to varying degrees, and with sort of unusual argument parsing by other Unix tool standards. And then, of course, that's not the end of things. You also have these compiler adjacent tools that are part of the C and C++ build ecosystem, like the standalone preprocessor, linker, archiver, assembler, and tools to detect libraries, tools to detect include paths, so on and so forth. So to accurately instrument a build system, you have to be at least partially aware of all of these things, which is unsurprisingly a pain. So what Blight does is that. Blight is a high-fidelity build instrumentation framework. Critically, it's both build and meta-build agnostic. It doesn't care how you run it. As long as it can sort of wrap the C, C++, CPU processor, linker, assembler, and archive commands, you can run it through any number of build or meta-build systems. As a design goal, it's sort of minimally invasive. We don't want to do what Bear does, where it sort of hacks its way into various commands by LD preloading throughout the build system, or propagating a shared object throughout the build system with an LD preload. We don't want to do that because that's prone to error. As part of what Blight does, Blight actually injects what we call actions into the build system. And actions can be configured by the user and also filtered by the tool that they're on. So it actually can be run for every single tool that gets run, or just for C++, or just for C, or just for C and C++, or any other sort of set of predicates. And we've built in some actions that we think are useful into Blight's default distribution, including profiling, recording, flag injection, and flag removal. So what it actually looks like to use it is, well, it's just on pip. You can install this right now. You can do pip install Blight, eval this. This just injects the wrappers into your environment. Configure the action you want to run, and then just run any build system you want. Make is listed there because it's simple, but literally any build system should work. It's not shown, but you can also, Blight actually also has support for misbehaving builds that will hardcode GCC or Clang instead of using CC or CXX. And also, you can, of course, run multiple actions in a single build. So, for example, you could do both ignore, werror, and also record in the same build. And now, hopefully, I literally just recorded this, so we'll see how visible or how useful this is for people to see. But in essence, I should preface this. Michigas is another tool that Trilobits has developed. It's a large C and C++ code base that has multiple levels of nested make, CMake, Bazel, and a custom Intel build system all within it. And what we'll see here is we'll see Blight actually correctly instrument and wrap its way all the way through all of those nested build systems. So you'll see me, once I actually copy and paste this in my recording. There we go. What you'll see is I've done that. I've set up my action, and then I'm just going to run make in parallel And what blight is doing behind the scenes is it's propagating itself. Oh, I also forgot to mention there's also a Rust build in there. Blight doesn't currently instrument Rust builds, but it can with relative ease. So that's just to say that it doesn't interfere with the Rust build. But what blight has done, it's correctly propagated itself all the way through all of these different nested builds. It's gone through make, recursive make to C make to C make to make to C make to Bazel, make to C make to weird intel thing, and then make to just direct Bazel. And so once this finishes building, you'll also see I dump out some of the results of this instrumentation run. Any second now. Yeah, so you can see it also did a Rust build in the background. Okay, yeah, and so here are just the individual invocations that it ran. And so you can see it records the stage, it records the standard, it has sort of high fidelity models internally for these, and it even records sort of the nested weird Intel Z build thing. So, that's it. If you want to go play with it, it's on GitHub. Like I said before, it's a single pip install away. It has no native dependencies at all, so it should just work on any modern Python 3 install. We also have this blog post out called High Fidelity Build Instrumentation with Blight. And then also there's public docs available for both using it and for implementing new actions within it on our github.io post. And that's all I have. So go wild.
Okay, great. Thank you, Will. We have some time for a couple little questions, if anybody would like to. You don't have to raise your hand. You can just blurt it out.
Hey, I have a question, Will.
Yeah.
Yeah, this is really cool. I just wanted to clarify one thing. So you say that it works on like any like build system, like CMake, make, whatever. Is there the caveat that the low-level tools need to respect like the CC and AS and whatever environment variables for this to work?
That's a really good question. Originally, yes. Currently, what we do is we have what's called a swizzle path mode, and that'll actually inject swizzled versions of CC and CXX into the path ahead of the normal CC and CXX. So even if the build system hard codes, for example, a call to Clang or to /bin/cc, that is the one case that won't work. If they hard code /bin/cc, I can't do anything about that. But if they do just CC or /bin/ or just GCC, we do correctly catch those.
Okay.
Yeah.
What if you have just this like a random compiler? I guess this is maybe not implemented in the compiler, but if your coworkers' bash scripts don't check for CC and stuff, will it still work with those?
It should, yeah. As long as it calls, like, for example, Clang directly, that'll get picked up by the swizzle path.
Okay. Okay, thanks.
Mm-hmm.
Do you have a way of recording environment variables?
It's not currently implemented, but yes. It's just I just have to capture it with every call.
Okay. It's pretty important for compile commands.
Mm-hmm.
Okay, great. We'll leave it at 2 questions. If anybody else wants to see more information, obviously the repository is open source. We have a blog post that summarizes how to use it. I think there's even some little recorded screen caps from possibly using it. I don't know. But all the info's out there. And I didn't plan it this way to be kind of a counterweight to Clint's talk, but I guess it works out pretty well. So if you can build, use Blight. If you can't, semgrep.